Namaskar everyone. Today we are here to discuss some basic problems that we can encounter in learning Python programming language or any programming language. Uh, for example, if we take a particular question, if someone asks you to check if a particular provided number is an Armstrong number or not. Now, right, first we have to know what is Armstrong number. So let's start. Before that, I just want to tell you that this will be a series of providing you the answers, the codes of the basic questions. Basic questions coming to my mind right now. For example, square root of a number, cube root of a number, how to apply power function in Python, then to check if a number is a prime number or not, to display a prime factor of a number, and to check if a number is perfect number or not, to check if a to display Fibonacci series. So we'll continue the series. I'll do that. So let's not waste any more time and let's just start. First, we have to know what is the Armstrong number. I'll explain that. See, this is a list I provided in which there are different numbers: 153, 370, 345, 678, 908. Now, 153 is an Armstrong number. I'm just telling you before the code runs, before we write the code. See, 153, for example, what is an Armstrong number is if you take each digit of a particular number, in this case, the number being 153. So, again, I'm repeating, if you take each digit of a particular number, that is 153, so each digit will be 3, 5, 1 if you take from right to left. So 3, 5, and 1. And you take the cubes of this number. For example, 3 cube, 5 cube, and 1 cube. And you sum them all. You sum it up. You add all those 3 cubes. For example, 3 cube 27, 5 cube 125, and 1 cube 1. So you add them. So 27 plus 125 plus 1. The answer, if that sum, if that total will be equal to the provided number, or if that is equal to the provided number, it is an Armstrong number. Let me just show you. For example, if the number is 153, we take each digit 1, and you take the cube. 1 cube is 1, 5 cube is 125, and 3 cube is 27. The total comes, right? Do the maths quickly. 1 plus 125, 126, plus 27, 153. So this is an Armstrong number. Again, if you take a number, for example, 370, I think this is also is an Armstrong number indeed. So 3 cube, which is 27, 7 cube, which is 343, and 0 cube is 0. So 343 plus 27, 343 plus 20, 363 plus 7, 370. So we get what? 370. So this is an Armstrong number. Now see, for to know if a number is an Armstrong number, we must keep few things in mind. One, what we want in a code, we want the sum of cubes. So we want the total first, we want the cube second, and we also want to take out the unique digits. Matlab each digit, right, separately. So we want to just take out 3 from 153, then 5 from 153, then 1 from 153. So these three things are main thing. If you can understand that, you will be able to check. It's a very easy code. Let's start. So we need a for loop. So for I in, again I'm saying you should have the basic Python knowledge, but very basic. If not, even I'll tell you some things. So for I in what n, this is a for loop. So I being, for example, every particular digit as a singular digit, right, a number as a singular number: 153, 370, 345, 3678, 908. So for I in n, what we want, again I said we want a total. So let's take total 0. What we want is a temporary, for example, temporary n equals to I. So here, why we need to store temporary n? Because we'll change it. We'll apply a while loop and we'll change the value of temporary n, because we need it, because we want to take out the single digits. You will see in a while. Then we'll apply the while loop. The condition we'll provide to the while loop is while that temporary n is greater than 0, we'll apply the loop. Now we want to take each digits out. So what we'll do is, for example, the digit is temporary n is what? 153. So 153. So well, let's do it. So 153, we'll say single digit, just a variable I've named. You can name it a digit. If we want to take 3, that is the ones digit. from 153, what we'll do is we'll take that I, which is 153, and we modulus it with 10. The moment the exact moment we do that, so 153 modulus 10 is 3, right? We'll get that. Even if you take the second I, which is in this case second iteration, the number which in this case is 370, you get 0. 345, you get 5. 678, you get 8. So unit digit you can get from this. The moment we have that, we want a cube now. Cube will be, I'm using the power function. Let me just use it, then I'll explain it how to use the power function. So power, provide on which you want to apply the power and which power you want. Now there's one more argument of that, and that is modulus. Let me just show you. Yeah, equivalent to base to the power exponent with two arguments. So I provide two arguments, single digit and 3, or base to the exponent modulus mod. Well, this is mod with three arguments. So if I provide the third argument 10, the meaning will be single digit, which is this, which is 3 in this case, to the power 3, 27 modulus 10. So answer will be 7. But we don't need this, so we'll take it out. Now we have got the single digit, which is 3 cube 27, right? This will be 3, this will be 27. Now we want what? Total plus equals to what? The cube, because we want to store the value in total, because at the end we'll check if this total is equal to that I, then only we'll say that it is indeed an Armstrong number, otherwise not. So we'll give that if else condition at last. It's fine, but see, the main headache is that you do not just want 3, you want 5 as a single digit, you want 1, that is you want a hundreds place, you want a tens place, you want a hundreds place, and then many more if the number is big. So how do you take 5 out of 153? The question is, how do you take 5 out of 153? You'll apply a division. Now, well, I'll explain. What we have to do is we take that temp pair n, which is 153, and we equate it to a temp n. We divide it with 10. The moment we do that, we'll know that now what we have gotten is 5 or 15. So we want 15. The moment we get 15, now temp n is greater than 0, 15. The same thing will happen, but 15 one's digit is 5. 5 cube is 125. Total, what we'll do is 125. So it will keep on changing. Now it has happened. If we take a number a is for example 2 and b is 4. Now I'm just taking a moment to explain you how what is division, because you won't understand if I don't explain this. 2 is 4. Now for example, if I print what I give c, for example, c is 1a single division, single slash, this is also a division, single, right, single slash b. Another I gave b equals to a, but this time 2 slash b. Now, these two are divisions only, but different meaning. Let me print c and let me print d. See, let's check. The answer is zero point 0.5 and 0. See, the zero point 0.5 is c. C is what? Single division. This is a float division. If you check the type, the answer will be, let me just put one bracket. The answer will be class is float. Now this is int. This is int. If you check the type, I hope it's int. Yeah, it's int. So what's the value? What we took? 2 divided by 4 is zero point 0.5 actually. But it will remove the decimal and it will take only what? Let's remove the type and let's get the answer again. It's only, you remove the decimal place and you take that 0. For example, the one units, sorry, not the unit series, but you remove the decimal and take the rest. That is exactly what we want from here, right? See, now we have written this entire block of code. Let us understand the while loop here, the function of the while loop. It says that while temp underscore n is greater than 0. Is it true? Yes, it is true. 153 is the temp underscore n value. So 153 is greater than 0. It will enter into the while loop. The unit underscore digit equals to temp underscore n, which is 153 modulus 10. The answer will be 5. Then it will take cube equals to power function unit digit power to the 3. It will take 5 to the power 3, which is sorry, in this case first unit digit will be 3, then 3 cube will be 27, and then in total we'll increment the value. It is 0 right now, it will be 27 now, right? But now, do we want for the second iteration 153? Just think about it. Just give it a second. The answer is no, we don't want 153. We want 15. Now, why we want 15? Please again think about it. When we got 153, we gave the unit digit 3. We wanted 3 because we wanted the 3 cube. But now we don't want that 3 cube. We have gotten that. We want 5 cube. For that, we now want 15, because 15 will go into the iteration. It will be 15, 15 unit digit will be 5, 5 cube will be 125, and it will be 127 plus 125, which is 152, right? And then what we wanted 1, because then 1 cube it will be 1, 1 cube will be 1, 1 again, 1 unit it will be 1, 1 cube is 1, and then we'll add here, we'll increment it by 1, and it will be 153, and then the loop is over. This is why we use this line of code to shorten the number, to change the number, because that is how every time we'll shorten the number, we'll get the unit digit, we'll shorten the number, we'll get the unit digit, we cube the unit digit, we store in the total. That is in its entirety what we are doing. Okay, if now total is equals to actually n what we sorry I what we provided, then you print that this number is an Armstrong number. Else you print this number is not, or let's just do it short, not an Armstrong number, right? Let's just check. I hope it will be a correct answer. See, the number is an Armstrong number is an Armstrong number, which is this and this, not an Armstrong number, not an Armstrong number, not an Armstrong number. That means the first two are Armstrong number, the rest are not. So this was it. Thank you for listening to me. I hope this will help you. Yeah, many more to come. Please watch.